My name is Anton Kochkov, about reversion firmware using Radare tool. Sorry for the technical problems. I will try to show this way my slides. A few words about me. I'm working for the security code company from the Russia, researching booting processes of the computers. This talk I will show, in this talk I will show you everything of the all firmwares you can find in your computers or laptops. What's the main goal of this work? First, of course, it is important to be sure you have full control on your hardware, and you will need to find that all pieces of your laptops, computers, or mobile phones are under your control, and you know that there is no any backdoors or any other malicious things. And the second goal is to implement open source alternative for these firmwares to run on these chips. This is a computer decades ago. You can see still complex structure which reminds a simple network. And there is a much more complexity these days in your computers. I will show you. This is a simple schematics of the booting process of the Intel laptops. Sorry for the too small size. It's hardly readable now, but you can see how complex these connections, and this means that you will need to handle security to verify that you have hardware under your control. Handle this is like a network, not like a simple piece of hardware. And you will need to be sure that all connections between all parts of this scheme is secure, and you have knowledge how this works. Let's start from the small review of the possible firmwares which you have in your computers. For example, microcode in your processor. This is a completely undocumented firmware, and it runs on each modern x86 processor. And only a few researches were done for this. And you can see that last research that was done in 2013 year found that microcode firmware is encrypted using RSA and checking signature while loading, while signature is CHA1. Next slide is a modern future of the every Intel chipset, and it is a completely independent processor inside your CPU or the South Bridge. It depends from the versions of the AMT. AMT is a complex technology, and you can find a lot of information which were found by Igor Skashinsky in his researches, and other interesting things like versions of the hardware used inside the processors, like in the early versions there were ARC processors, while later that was changed to the Spark, and later it was changed for the Quark core. Next chip which you can find in your processor chipset, it is AMD EMC. It is mostly for the power management tasks, and it is completely undocumented too, and it is reversed completely for the few chipsets, and you can find in the internet experimental firmware available from the Rodolphe Marek. One more embedded controller. It is AMD SMU. It is much less documented than other parts of chipsets, and it is also handles power management stuff and possible other. It is not very knowledgeable, except AMD employees. You can find that Altera LM32 processor inside this chip. Next, independent computer inside your computer. It is a possible network card. For example, this Intel card, as a net controller, have its own independent CPU, which can be, of course, bypassed, and a few research found that you can refresh your network card, not the PCI option ROM, but internal firmware, and you can run a CCH server inside your network card. And of course, this is undetectable completely from the host side. Next part of the software running on the independent chip, it is a USB 3 implementation. It is old known NEC V815 architecture, and it is completely implemented in software, so you can download the firmware and find the actual bugs inside your USB stack. And you can find the vulnerabilities inside these firmwares. Next part, already widely known, it is a HDD or HDD firmware. And there is already two very good researchers about reversing Seagate and Western Digital HDD firmwares. And you can find that you can run completely independent code which can hide data or store data from your HDD, and also undetectable from the host side. One more, it is a mouse. It can be completely independent computer too. For example, there was a research done by Jakob Maskevich in this year on the Usenix. And in this research, they reversed its firmware, which is running on the Atmega CPU. And they took an example, mouse Logitech G600 model. Next chip which you can find in your laptop, it is an embedded controller. This chip is mostly for the talking with keyboard, for talking with system flash chip, for the talking with sensors and various power management stuff. And you can find that most of the keyboard data passing through this chip. There is a few manufacturers of these chips, and each one is independent computer too. Most of them are very known 6-bit microprocessor from the Intel. And you can find a lot of information about embedded controllers on the Coreboot site and page. There are options that you can run your firmware on these chips, because most of the laptops doesn't verify a signature of this firmware. Next chip is a touchpad. You can find that in your touchpad there is an independent microprocessor again. Usually it's a AVR or PEC architecture, and there are no public attacks using this chip yet. But I think there will be. One more chip that you can find in most of the laptops is a webcam. Because webcam is usually completely independent computer too. And to process your data, it runs its own firmware. And for example, you can upload this firmware on the webcam processor from the Windows user mode. There were recent attack using this technique. One more, it is ASD MMC cards. They also contain small processors with its own firmware. And in fact, as that's already said on the previous researches, you can hide some data on this card, or you can save stored files which were deleted on the some hidden place. One more chip inside your computer, it's a BMC that's mostly for the servers, and this is a very complex system. In fact, it is a completely independent operating system with a lot of services running on there, and this part is mostly secured this time, but early implementations were very simple and allowed to upload your own code. Here is a simple scheme for the IPMI, which is in fact service running on the BMC controller. And you can find various versions of the vendor implementations for the BMC, like HP ILO, which is 66 megahertz processor running the very big operating system, which is stored on the NAND flash, and you can refresh it from the host side. Dell providing its own implementation for the BMC2. It is external PCI card on the earlier versions, and completely embedded on the main board in the later versions. And of course, you already know that there is code running in the on the main processor, which loading from the PCI option ROMs, and you can find that this code could be very complex, and there were attacks which were using legacy BIOS or Wi-Fi, and some researchers like Darmawan Salihan wrote completely operating system running from the PCI option ROM. Let's talk about how to reverse them. I want to present a Radare tool, which some of you already know. This is a reverse engineering framework and tool set, which consists from the many various tools, and main is AR2, which is in fact console disassembler, console hexaditer, and you can find example of the screenshot running from the console. Here is the main commands like print disassembly, show flags or labels, seek and add function, add comment, mark as data, write back to the file. And a lot of other simple commands which you can find similar to the either pro commands or case. Let's run the demo. Here is the opened file of the starting point of the UEFI, which is extracted from the main image. And this is a test executable file, which is loaded in the Radare. And you can see that Radare already determined jumps, and if you type after analysis, you can find that there is functions were determined, and you can see call graph if you run okay, call graph doesn't work. There is another modes like hex editor, and you can export in the hex values, and of course main disassembly mode. Next file I will show you, it is a CompuTrace software, which is in fact part of the most modern laptops, and which can be used for the remote control of the computer. There is a good research on the old CompuTrace versions, which were were built for the legacy BIOS, but there is a new version for the UEFI, and it does support a few Linux versions too, not only Windows. So if you have a laptop with this firmware, you can be sure that CompuTrace can be installed into your operating system while booting. Next example will be part of the embedded controller running on the actual laptop HP Dell Vostro V13, and you can see that there is support for the loading scripts, which in fact contain commands for the Radare, and you can just load them, and they are executing and providing you way to the add functions, add comments, and all the comments you have in the Radare mode. Here is the content of this file. You can see various commands for the Radare. First command adding, it is too small to read. First command adding comment to the address, and second command is adding a function, creating a function with the size of 36. And next commands just adding more comments, and last command is a seek to this address. Next, firmware which you can reverse using Radare tool is Intel AMT ARC, based on the ARC architecture, as like a Spark 2. But to unpack modern AMT versions, like up to 7 version, you will need to break the Huffman encryption. That was partly done by Igor Skashinsky and Blah from the Smashing the Stack. Here is actually a kernel of the operating system running on the ARC processor in the Intel AMT. You will need to specify the actually architecture of this firmware, which is ARC, to load this file, and you can see initial jump table for the setting up interrupts. Some of the opcodes are vendor specific, and Intel overrides them, so we just doesn't know for sure what they mean, because they are not documented in the data sheets. Next example will be one more embedded controller with much more rare architecture. CR16. As you can see, here is the initial part of the firmware, which is running actually on the embedded controller and can be analyzed for the vulnerabilities, and you can find here a bug and refresh him from the user mode. And you can install whatever you want in this chip. To help reverse Wi-Fi, there is a very good tool from the Nikolai Schley Wi-Fi tool, and it allows to extract parts of the whole Wi-Fi firmware, and you can just analyze them independently using Radare. Previously shown CompuTrace firmware were extracted this way. And various another tools which can be used for the non-UEFI firmwares like BIOS extract, which can be used for the legacy BIOS images. And you can actually dump code from the memory and dump from device. If you have some cheap equipment, like buyer's bus pirate or similar. And of course, Radare can be integrated with Serialize, Panda, and Avatar tools to perform both statical and dynamical analysis using the GDB connection protocol. And in fact, you can use tools like FlashROM or external programmer like Buzzsprout or Raspberry Pi to flashback modified versions of the firmware, which can be reversed and patched using UEFI tool and Radare, because UEFI tool can not only unpack but can also pack back, so you can patch every part of the firmware, each PE file of this or TE test executable, and flash it back. Same things can be done from the for the embedded controllers too, like keyboard controllers, embedded controllers in the laptop, and a mouse. Thank you for your attention. Any questions? And sorry for the